In this video, we are going to discuss about the logic implementation using programmable devices. On completion of this topic, students will be able to study the design and operation of semiconductor memories frequently used in the application-specific circuit design. So first we are going to see about the programmable logic devices. So here this programmable logic devices is also known as field programmable logical device. So it consists of an integrated circuit that can be configured by the user to implement different digital hardware. So this IC contains large number of gates, flip-flops, etc. that can be configured by the users to perform different functions, and it is known as the programmable logic device. So the internal logic gates or the connections of this PLD can be changed or configured by a programming process. One of the simplest programming technologies is to use fuses. In the original state of the device, all the fuses are intact. This programming the device involves blowing those fuses along the path that must be removed in order to obtain the particular configuration of the desired logic function. So the main purpose of this logic devices, it permits elaborate digital logic designs to be implemented by the user on the single device and can be erased or reprogrammed with a new design. So major thing is major things in the standard ICs, or they can require hundreds or thousands of ICs, can be desirable amount of the circuit board. It has been large number of problems or large number of the testing strategies. So this can be implemented, or this can be erased, or it can be reprogrammed with the new designs. So that is, it is more faster, and also it requires lower power requirements, less costly assembly process with high reliability. And the advantages of the blade is cost effective, short design, and is well suited for the academics of the academics and prototyping. Mainly the advantages of this programmable devices is more faster with less costly assembly process, high reliability, that is fewer ICs and the circuit connection means easier troubleshooting and availability of design software. Main problems of the standard IC are they require hundreds or thousands of these ICs, considerable amount of the circuit board space to deal with, cost in inserting, soldering and testing. So here also it is a reprogrammability. This can be reprogrammed without being removed from the circuit board, and low cost of design, immediate hardware implementation. And this PLDs are having the three fundamental types of the standard PLDs. A fourth type of the PLD is the complex programmable logic devices, which has billions of gates. In order to show the internal logic diagram, it is necessary to have the special symbols for this. So this uses address coding, where there are several advantages over 7400 series, and one part is damaged or one part of this is error, it can be replaced. So one chip requires less board area, power and wiring than several do. This is very flexible, and it can be changed in the logic gates, which require a number of wiring boards, rewirings. So rather simply replacing one PLD with another has been programmed with a new design. And the types of PLDs are read-only memory, programmable logic array, programmable array logic, and generic array logic. So PLD is divided in two types, SPLT and HCPLT. From that SPLT, it is programmable memory, programmable logic array, programmable array logic, and generic array logic. HCLT, it is a complementary programmable logic device and FPGA. So simple programmable logic device, or simplest, smallest and least expensive forms of programmable device, which can be used in any types of boards for replacing the 7400 series. It can be either used in fuses or non-volatile memory cells also. So programmable logic arrays. Programmable logic arrays is a fixed architecture with the programmable AND gates, which is followed by the programmable OR gates. It is a type of programmable logic device used to build a reconfigurable digital circuits, and also it is an undefined function at the time of manufacturing, but they are programmed before being made into use. So this is comparison. It has a programmable AND gate and programmable OR gate. It has a programmable OR gate, AND gate, and but a fixed OR gate. In the ROM, it has a fixed AND gate, but it is a programmable OR gate array. So this is a set of the programmable AND gates which link to a set of the programmable OR gates, which produces an output. And programmable logical array is to implement the logic functions in the digital structure circuits which has a programmable AND matrix and OR matrix. Here the word programmable does not indicate the programmable logic array. It is a field programmable, and also they are embedded in most complex and numerous integrated circuits such as microprocessors. So this PLD configuration, it is a combination of the digital logic device and memory, stores the pattern which it is programmed with the EEPROM and static ROM and flash memory. The configuration SRAM has a reprogrammable and volatile. Flash is also reprogrammable but it is non volatile. EEPROM is reprogrammable out of the circuit, but it is not volatile. EEPROM is reprogrammable in the circuit, but it is not volatile. Quiz questions on logic implementation using programmable devices. A ROM which can be programmed is called MROM, PROM, EROM, and EEPROM. Thank you.